In this video, we are going to analyze graphs. We're going to talk about domain and range, intervals of increasing and decreasing, local maximum and minimum, as well as how to use the graphing calculator. So for graph, for number 1, it wants us to state the domain and range for each graph. So we're talking about domain, we are talking about the x values. So I'm going to look to the left. My most left x value is -4. My function is continuous, and then my most right x value is going to go towards infinity. So my domain is going to be -4 to infinity. I'm using a square bracket on -4 because -4 is included since it's a closed circle. For the range, we are talking about the y values. So we're going to look for the lowest y value, which again is this arrow pointing down. An arrow pointing down for our range is going to point towards -infinity. The maximum for my range is up here, which is at 4. So 4 with a square bracket, because again, that's an included point. For the domain of G, I'm going to look all the way to the left, and I see this arrow is pointing to the left. So that's going to point towards -infinity. Then I do have a break here, but at the value of 2, I do have a closed circle, and then it continues on with an open circle. And this point's going to go to the right, so my domain will be -infinity to infinity. When we're talking about the range, I'm going to look from the lowest point. So the lowest point is down here at -4, and it is included. And my highest points are pointing up towards positive infinity. For H, the domain, left side, and it is a continuous function, so 1, 2, 3, 4. So -4, and it's included. 1, 2, 3, 4, +4, and it's not included because it's an open circle. My range, the lowest point here at -4 is also not included. And my highest point here at 4 would be included. All right, let's review function notation. So if we are talking about f of -3, I'm going to use the f function, which is here, and I'm going to go to my -3, 1, 2, 3, and I'm going to go down and I'm going to see f of -3 is -1. How to find g of 2? I'm going to go to where x is 2 on my g function, which is right here. And there's two choices. There's this open circle and the closed circle. Well, the open circle is a hole, so I want to go to the closed circle, and I can see that g of 2 is -4. When we go to h of 4, I'm going to go to where x is 4, which is right here. It's actually a hole, so there's no point there, so it is undefined. When they give me f of x equals 2, they're looking for the x value, so I'm going to go on my graph where y is -2, and I actually have 3 spots. So we're just going to estimate. One of my x values will be about -2.6, this first one right here. The next one right here is a little bit bigger than 1, so we can call it -1.1. Then we have another one right about here, which is just shy of 4, so we'll call it 3.75. Those estimations don't need to be exactly the same as mine, but those are about what they would be. For this one, it says when g of x equals 4, what is x? So I'm going to go to where g is 4. I'm going to go over. So 1, 2, 3, 4. X is also 4. All right, now it's asking where is f increasing, and I'm going to erase some of this graph because I've drawn all over it. I'm going to do it for all of these to make it easier to see. So intervals of increasing are when my y values are getting bigger. So if I look, my intervals of increasing is going to start here and continue to here. So the x value here is -2. And it's going to stop increasing at 2. For decreasing, it's going to decrease from here to here, and then from here to here. So the first section is going to decrease from -4 to 2, union 2 to infinity. So it starts decreasing again here, and this arrow is pointing down, but it's also pointing to the right, which means it's pointing towards positive infinity for the x. Remember, with intervals of increasing and decreasing, we're always going to use our x values only when we're writing those out. All right, when is G increasing? So let's look at G. I can see G is increasing from here to here. It is not increasing, it is decreasing from here to here, and then constant from here to here. So it is going to increase from 2 to infinity. The last question asked, when is H decreasing? Well, I can see that H is decreasing from here to here. So it's a little bit hard to see, but if I were going to estimate, it's a little bit shy of 1, so maybe 0.75, or if you said 0.8. So I would say H is decreasing from 0.75 to 4. All right, now we're going to use these same graphs and talk about what it means to be a local maximum. So that's just a place where we have a highest point or a lowest point. An absolute maximum or minimum would be the absolute highest or absolute lowest. This is just a highest or a lowest point. So when it talks about value, we're looking for the y value. If we're talking about a point, if it asks for a maximum point, then we're looking for a coordinate. So it's really important to know the difference. A y value is we're looking for the y value and then asking when it occurs. And the x value, when it asks for a maximum point or a minimum point, we want to give a coordinate. So f has a local maximum at, let's take a little closer look. I would say right here is the maximum. So that value is 4, and it happens at x equals 2. So when I'm finding the maximum value of 4, which occurs at x equals 2. The point would be 2, 4. Now it's saying f has a local minimum. The minimum would occur right here when y equals -3 at x equals -2. So the minimum value is -3, and it occurs when x equals -2. If it asks for the point, it'd be -2, -3. Now let's take a look at these little images. So it says the formal definition of increasing and decreasing. F is increasing on the interval when the one x value is smaller than the other x value. So basically, as my x's get bigger, my function or my y's are getting bigger. If it's decreasing, that means as my x's are getting bigger, my y's are actually decreasing. So keep in mind that your x's are always increasing, but your y's are going to increase or decrease depending on the situation. When we're talking about local maxima and minimum, a function can have multiple local maximums and multiple local minimums. So keep that in mind. There could be more than one. If they use the word absolute, then that means that's the absolute highest or the absolute lowest. For the second half of these notes, we're going to be using the graphing calculator. So if you need help finding these features, I'll do my best to explain. First, we are going to enter this equation into our y equals on our calculator, and we want to use a standard window, which you can find as option number 6 under our zoom button in the top. When you look at the graph, you can see that the domain is going to go to -infinity to positive infinity, as well as the range. Now on the graphing calculator, when they give you an x value, if you go to second trace and you use option number 1, which says value, you can type in -3. You could also just plug -3 into the equation above, but either way you should get an answer of 21. When you're trying to find an x value given a y value, you're going to want to enter in 5 into y2. and then find the intersection. You could also do this under second trace. And it's going to be option number 5. So when you do that, you're going to get that x is negative 2.095. The next section talks about the local or relative maximum. This is again going to be under that second trace menu, and you're going to use option number 4. So when it talks about the value, you want to make sure that you're giving me the y value. So the value would be 1.089, and then you want to say where it's occurring at. It's occurring at x equals 0.816. Similarly, when you're talking about relative minimum, second trace, but now it's option number 3. When it talks about the minimum point, this is where you're giving a minimum coordinate. So that minimum point would be negative 0.816, negative 1.089. So make sure we understand the difference between a value is the value of the maximum, the y. A point is going to be a coordinate. That's really important to know the difference between those two. Intervals of increasing and decreasing. These are determined by our maximum and minimums. So if we look at our function, I can see that it's decreasing from negative infinity until it hits that minimum at negative 0.816. Once it hits negative 0.816, it starts increasing and stops increasing when it reaches the maximum at 0.816. Sorry about that. Then it's going to start decreasing again at that point and decrease forever on. So those local maximum minimums really see where our graph changes direction, so where it's increasing versus when it's decreasing. And remember, we read a graph from left to right. Now it wants to know what are the values of x when f of x equals 0. We're going to use the 0 option for this because we're looking for our x-intercepts. So again, if you go to second trace, we're going to use option number 2. And when you do that, you will find that we have 3 x-intercepts. Well, you'll have to do second trace, option 2, actually 3 times. One at negative 4.14, one at 0, and another one at 1.414. So actually 3 x values or 3 x-intercepts. All right, so now I want to know what are the values when f of x is less than 0. So basically when y is negative. So if I were to sketch a little sketch of the graph, not the best, but it works. This is that x-intercept of negative 1.414. This is that minimum. This is that the origin. This is the maximum. And this is the other x-intercept, 1.414. So we're looking at where are the spots where the graph is less than 0. That's going to be from this x-intercept to this x-intercept, and from this x-intercept to infinity. So we would say, oh, x is less than 0 between negative 1.414 and 0, as well as from 1.414 to infinity. Our last graph is now just using, and it says absolute extrema. Absolute extrema means that there's an absolute highest or lowest point. It doesn't occur in this case because we have this part that goes up forever and this part that goes down forever, so there can't be any absolute max or mins, so in this case there are none. Our last graph gives you a graph and asks for the domain and range. So again, domain is our x values, range is our y values. So my domain starts at negative 6, and it's going to be a closed circle, and it's going to go to negative 2. Then it picks up again here at 0 and continues to 3. Then it picks up again at 4 and continues forever. For the range, switch colors here. My lowest point is here at -5, and that piece goes up till 4. But because of the overlap, this piece at -3 would fit inside between -5 and 4. This piece kind of takes over because it goes to infinity. So where this stops, this kind of picks up. So I can see that my range is going to be continuous from -5 to infinity. So even though there's holes, so there's a gap hole here, it's filled in over here. Same with here and here. So my range will be -5 to infinity. Now when we're looking at evaluating, f of 5, y would be 2. F of -2, well, there's a hole there, so this is undefined. This one's a little bit trickier. I need to do 4 times f of 6, so 4 times something, minus f of -4. Well, f of 6 is 4, and f of -4 is -3. So I'm going to have 16 minus a -3, which would give me 19. Because when you minus a negative, you get positive. Now it's asking about intervals of increasing and decreasing. So when I look from left to right on this graph, this piece is constant, so it doesn't fall into either category. This piece is decreasing, so it's going to decrease from 0 to 3. This piece is increasing, so it's going to increase from 4 to infinity. The last part says, what is the value of x when f of x equals 3? So I'm going to go to where f of x equals 3, which is right here. And the point is right there. So x equals 1, as well as if I keep going over here, it's about 5.5. What values of x when the function is greater than or equal to 0? I'm going to clean this up really quick again. So when the function is greater than or equal to 0 is here as well as here. So this is from 0 to 2 and then 4 to infinity.